In this video, we will discuss about the static and dynamic systems. Memory-less systems are said to be static systems, whereas memory systems are said to be dynamic systems. For example, if you write the response of the system like y of t is equals to n x square of t, and you want to check that the system is either static or dynamic, so you suppose that you check the response of the system at t is equals to 1, and you see that y of t is equals to 1 is equals to n x square of 1. So this shows that the system depends only at the present states. So that is why you can say that the system is a static system. Second example, you can say that y of t is equals to 2x of t plus 5x t minus 1, and again you want to check the state of the system. You see that you want to check the response of the system at t is equals to 0 and check the response of the system at t is equals to 0. So if you insert t is equals to 0 in this response, you will see that it is 2x of 0 plus 5x of 0 minus 1 is equals to minus 1. So it means that the system response depends on the present state and the past state. So it means that the system is a memory system. So it is not a memory-less system. So that is why you can say that this system is a dynamic system. Now we can see what is causal system and what is non-causal system. A system is said to be causal if its response is dependent upon present and past inputs, and it doesn't depend upon the future input. For example, if the response of the system is given by this equation y of t is equals to x of t plus 1 divided by x of t minus 1, and you can check the response at present time t is equals to 1. So the response at t is equals to 1 is equals to x at t is equals to 1 plus 1 over x. When you insert t is equals to 1, so 1 minus 1, the answer is 0, so x of 0. So it shows that the system response depend on the present state and the past state. So you can say that if the system depends on the present and past states, so the system is known as causal system. Similarly, you can see the response of another system y of t is equals to 2x of t plus 1 over x of cube t, and you can check the response of the system at t is equals to 1. So at t is equals to 1, so you can see that it is equals to 2x at 1 plus 1 over x cube at 1. So it shows that the system response depend on the present input. So you can say that the system is a causal system. So there is another example where the response of the system is given by this equation y of t is equals to 4x of t plus 1 over tx t plus 1, and you want to check the response at present time t is equals to 1. So which means that when you see that y of t is equals to 1 is equals to 4x of 1 plus 1 over 3x 2. So it means that the system response depends on the present input and the future input. So you can see that the future component is there. So you can say that the system is non-causal system. You can have another example whose response is given by this equation y of t is equals to x square t minus 2x t minus 1 plus 1 over x t plus 1. So you can check the response of system at t is equals to 1. So at t is equals to 1, you can see that the response of the system depends on present input, past input and future input. So it means that you can say that this system is a non-causal system. So we have important points. So the first point is all non-causal systems are dynamic systems. So what does that mean? We know that a non-causal system means the system which depends on the present and past and future inputs, or you can say that the future input component must be there. So it means that the system must have memory. So if it is memory, then you can system response depends on the future input. So future input means the system has a memory. So if the system has a memory, then you can say that the system is a dynamic system. The second point is that all dynamic systems may not be non-causal system, because condition for the non-causal system is that the future input must be the part of the system response. But for the dynamic system it doesn't depend, because for the dynamic system memory component is a compulsory, and which is also present in the causal system. So that is why not all the non-causal system are not all the dynamic systems are non-causal systems. Third point, all static system are causal system. Why? Because the static system are the memoryless system, and causal means there are only present input. So if the present input is there, then you can say that the system is a memoryless system. Memoryless system means static system. But all causal system may not be static system, because we have seen that in all the causal system or in the causal system you can see there is a memory component as well. Like if there is a past input, so and present input, the system is a causal system, but the past input is there, so it means that the memory component is there. So that is why you cannot say that it is a static system. So that is why all causal system may not be static system. The other is the invertible and non-invertible system. A system is known as an invertible system if the input appears at the output. For example, if you have input and the response of the system is there, apply on that input and you will end up with the output y. For example, if you give the input and the input is the impulse, then the impulse response of h1 of t of xt is equals to x prime t. And if you give that input to the invertible system whose response is h2t, then you can say that the output will be again x of t, because here you are inverting the response. Whatever the response is here, you are inverting the response over there. So that is why you are ending up with the same input that you have applied at the input. So that means that you can say that these systems are invertible. But if the input doesn't appear at the output, or you can say that y of t is not equal to x of t, then the systems are non-invertible systems. For example, in frequency domain, the response of the above system, you can write y of s is equals to x of s multiplied by h of x s multiplied by h of 2s. And where h of 2s is basically the invertible system, so you can write the response of h of 2s is equals to 1 divided by h of 1s. And if you insert that in this equation, h of 1s, the h of 1s will be cancelled with that h of 1s, and the remaining is y of s is equals to x of s. And if you take the inverse Laplace transform of this equation, you will see that y of t is equals to x of t. So it means that the input appears at the output. So that means that you can say that this system is invertible system. The last is the stable and the unstable system. A system is known as a stable system if it produces bounded output for a bounded input. Bounded mean you can estimate the value of the system. Unbounded mean the estimation is not possible, that the responses keep rising or exploding. For example, if you want to write the response of system with this equation, y of n is equals to x square of n, so it means that whatever the input of the system will keep squaring of that. So if for example, if you take the unit step as the input of the system, and you apply that input to this system, so it means that the square of the unit step is again unit step. So that means that the system is a bounded system. So input is a bounded system, output is again bounded system. So you can say that this system is a stable system. The second example, y of t is equals to 2x square of t. So you can again consider the unit step system as the input. So whatever the input is there, it will take squaring of the output. So again that the output is a bounded output, only its amplitude is 2. So if you apply bounded input and you end up with the bounded output, then the system is a stable system. The third example is y of t is equals to integral of x of t. So and you take the input x of t as the unit step and you want to calculate the response of the system, then you will see that the integral of the unit step is equals to t, which is a ramp function, and you know ramp function is a unbounded system. So it means that you apply unit step as the input to this system, and the output of the system is a ramp signal, which is unbounded system. So it means that the system is unstable system. So in the previous example 1 and 2, we have seen that the system are stable system, but in this third example you can see that the system is a unstable system.